Okay, in this concept we're going to talk about solving radical inequalities. Now, a radical inequality is an inequality that has a variable in a radicand. Okay, so a variable under the square root, or the cubic root, or the nth root, etc. To solve radical inequalities, follow these steps. If the index of the root is even, so, square root, 2, and then, or fourth root, or sixth root, etc., find the values of the variable that makes the radicand greater than or equal to 0. So take what's under the root and then make it greater than or equal to 0. Then solve this. Then after you get that solution for whatever makes the radicand greater than or equal to 0, then solve the entire inequality algebraically, and then you'll take the intersection of both of them. Right, both instances. Then you can check the solution. Let's look at an example. We need to solve the square root of 2x plus 3 minus 4 is less than or equal to 5. Since the radicand of a square root must be greater than 0, so 2x plus 3, first solve 2x plus 3 greater than 0 to identify the values of x for which the left side of this inequality is defined, right? Because again, if we had a negative number under the radical here, under the square root, this would not be defined, right? Well, you would get an imaginary number, but in this case, it has to be real for us to find real solutions of the inequality. So 2x plus 3 greater than or equal to 0, subtract 3 from both sides, so 2x is greater than or equal to negative 3, x is greater than or equal to negative 3 over 2. So to make the radical expression defined, x has to be greater than or equal to negative 3 over 2. So let's take a note of that. Then solve the entire inequality. So square root of 2x plus 3 minus 4 is less than or equal to 5. Add 4 to both sides. Right, so now we have 9 on the right hand side. Then square both sides, right? So 2x square root of 2x plus 3 all squared less than or equal to 9 squared. So 2x plus 3 less than or equal to 81. Just solve for x, standard algebraic manipulation. 2x is less than or equal to 78. X is less than or equal to 79. So for the entire equation, or the entire inequality, x has to be less than or equal to 39. But to make the square root part valid, x has to be greater than or equal to minus 3 over 2. So the full solution is this, right? So x is less than or equal to 39, but not up to negative infinity, right? It has to be greater than or equal to minus 3 halves. So the solution is only from here to here. Okay, this is the solution. Okay. So this way you ensure that what's under the radical doesn't end up being imaginary. Okay, it actually gives you a real answer. Now let's look at these exercises. Please pause the video, work on these, and come back for the solutions. Okay, so here we need to solve these inequalities. First we have square root of 2x plus 1 minus 2 is greater than or equal to 5. So again, two main steps. So make what's under the root valid first. So 2x plus 1, make that greater than or equal to 0. So that gives us x is greater than or equal to minus 1 over 2. All right. Then solve the entire inequality. So 2x plus 1, and then I can bring the minus 2 to the right hand side as plus 2. So greater than or equal to 5 plus 2, which is 7. Square both sides. So that gives us 2x plus 1 is greater than or equal to 49. Subtract 1 and divide by 2. So 49 minus 1 is 48, divided by 2 is 24, so x is greater than or equal to 24. Okay, now if we graph this on the number line, we'll have this. So 0, 24, minus 1/2, right? So it has to be greater than or equal to minus 1/2, but then it also has to be greater than or equal to 24, right? So in this case, we're not doing or, we're doing the and operand. And in the and operand, actually, this is not, you can't really consider this an and operand, so we have to take the x is greater than or equal to 24, right? Because now this makes the entire inequality work, right? This makes just what's under the square root work, but not the entire inequality. So in this case, we have to go with the larger number. X is greater than or equal to 24. Okay, which is in a sense actually the same as the and operand, because we're basically taking the intersection, right? So of the two conditions, x greater than or equal to negative 1/2 would give us all of this all the way to plus infinity. X greater than or equal to 24 would give us all of this starting from 24 all the way to plus infinity. So the intersection of both of them is just x greater than or equal to 24. Okay? So this would be the answer, not this. Let's look at the next exercise. Square root of 2 minus square root of x plus 6 is less than or equal to negative square root of x. So here we have two radicands, right? We have x plus 6 and we have x. So we need to test both of them to determine what makes them real. So x plus 6 greater than or equal to 0 means x has to be greater than or equal to minus 6. And x greater than or equal to 0, this radicand, means just x has to be greater than or equal to 0. Okay, so in this case, we would actually take the x greater than or equal to 0 as common to both of them, right? Because this one makes both radicands work. But this one makes just this radicand work. Okay, makes this one work, but not this one. So we have to take this one, x greater than or equal to 0. Okay? Now again, this is just a testing condition for the radicands. Now we actually have to solve the entire inequality. And what we could do is we could do some algebraic manipulation, right? We can do plus x plus 6 and then plus x plus 6. Then we can do plus x and plus x, right? These cancel, so we end up with square root of 2 plus square root of x is less than or equal to square root of x plus 6. Square both sides. So you'll get x plus 6 and then you'll get, let's rewrite this in ordered, actually we don't have to, so you just get 2 and then plus x and then plus 2 square root of 2x. Okay, here we have plus x and plus x, so we can subtract x from both sides, and we can also subtract 2 from both sides. So that's going to give us, so this will go away, this will go away, this will go away. 6 minus 2 is 4. So 2 square root of 2x is less than or equal to 4. Divide by 2, divide by 2. This goes away, this becomes 2. Now square both sides, so square the 2 and square this, right? So we have 2x is less than or equal to 4. So we have x is less than or equal to 2. And again, if we put this on a number line, so we have 0, and we have 2, and we have, you know, minus 6 somewhere here, right? We already said that for testing the radicands, we need to take the x greater than or equal to 0. So that is going to go all the way out to infinity, right? But then for the actual solution, we'll have x less than or equal to 2. So that would have gone out to negative infinity from 2, right? Actually, I can draw it, I can draw it down there so you can better see. So here. So the 0, the x greater than or equal to 0 is this, and then the x less than or equal to 2 is this, right? So the intersection is actually this portion, okay? Both of them have to be valid, okay, for the entire equation to work. So again, this is the equivalent of an AND operand. So we really have x greater than or equal to 0 and x less than or equal to 2. This is my solution. Okay? So this is the solution as represented here. All right. This is it for this concept. See you in the next video.